I'm not with you. I'm with you in spirit, and of course, I'm with you in video. And you should be on page 9 in your Unit 4 packet, Explain 1. I will go through and define these terms for you, and then I want you to pause this or have your substitute pause it, and then draw a model. And then I will put a model on here that you can check to make sure you're along the right track. All right, so our first one is the atom. The atom is the smallest particle of an element that can exist alone or in combination. And of course, this term was coined by Democritus. It means indivisible. But if we were to take, for example, H2O, in H2O I have a total of 3 atoms. Okay, so just draw some representative of what you think an atom would be. Pause the video then. Okay, now that we're back, I drew a triangle to represent an atom. Okay, it's the smallest particle. Okay, now we're talking about a molecule, and as we get more into bonding, we're going to define molecule further. Technically, it's just the smallest particle of a covalent bond, but here in your packet, it defines it as the smallest particle present in one type of matter. So if we had a bunch of water, H2O again, then we would say, okay, the smallest unit in water is a water molecule. So now pause and represent what you think a molecule would be. All right, now I actually drew 2 molecules. I drew water right here, H2O, and of course you didn't have to put the hydrogen and oxygen in there. You could just use circles. Then we'll use a different type of circle for oxygen just to show that that's a different atom. And these overlap because there is bonding. Water is a compound. Now let's look at this. This one is 2 atoms of the same type bonded together. That's why I had them overlap. This is actually called a diatomic molecule. Okay? And that means it's made up of 2 of the same types of atoms. The thing about diatomic molecules is they will not exist as single atoms in nature. They will always bond with another atom of the same type. This is called a diatomic molecule. And there are 7 of these diatomic molecules, H2, O2, N2, and then group 17, which are the halogens. They will all form diatomic molecules. Your halogens are fluorine, chlorine, bromine, iodine. Astatine also, but we don't really deal with astatine too much. And if you look on the periodic table, the 6 of these actually make the number 7. And that indicates that is a hint to you to remember that there are actually 7 of them. Hydrogen is not part of this block over here. It's up here. But you have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So that's kind of cool. And that's an easy way to remember it. Okay, now we come to element. An element, there's just one type of atom. And as I think you know, there are about 118 different elements. The elements we have found on Earth are the same elements so far that we have also are aware of in our universe outside of Earth. All the different elements are found on the periodic table. As we said before, some elements can exist individually. Those can be called monoatomic. Most of the elements are monoatomic. That means they only take 1 atom. And the other 7 elements are diatomic. And that means if they exist by themselves, they would combine as two atoms. And as we said, that's H2O2, N2, and then the halogens, fluorine, chlorine, bromine, and iodine. They always exist, two atoms bonded to each other. Of course, elements can also bond to form compounds. All right, so pause the video and do a little model of what you envision an element to be like. This is my model. That could be an element, and then I'm going to just use circles. This could be a diatomic. So this would be a monoatomic element, and this would be a diatomic element. Okay? And then we get to a compound. A compound is made of two or more elements that are chemically combined, and that just means they're bonded, so they can be broken down by chemical change. And these elements will always be in a fixed ratio, as we saw with the law of definite proportions. The other thing is a compound will have very different properties than the elements that make it up. So stop the video and do a little model of a compound. Okay, this would be my model of a compound. This is one element, and then these, I'd have two atoms of a different element. All right, then we classify matter, what we've been talking about, as either a substance or a mixture. Substances are elements or compounds, and the thing is that they are pure. And that just means they have the same composition throughout. They have a fixed ratio, and that does not change. So that would be a substance. And if you're going to do a model of a substance, well, think about it. Think about how you would do that. Pause the video. Okay, now if it was me, I'd say, okay, a substance could be an element. So I might have, like this, could be a substance. And then if I was drawing a compound, I might have something like this. One element and a compound made up of two different types of atoms, the circle atoms and the square atoms. But I'm showing that they're bonded by overlapping them. Okay, the last classification of matter is a mixture. And a mixture is two or more chemicals that can have varying composition. So they can be separated by physical means. You can separate a mixture by physical means. It doesn't have to be chemical. There's two basic types of mixtures, heterogeneous and homogeneous. The heterogeneous mixtures, you have more than one phase. You can easily distinguish the parts of the mixture. They're not uniform. An example of this would be like a pizza or a tossed salad. Those are heterogeneous, or a piece of granite where you can see the different minerals in the granite. And then the homogeneous mixture, which is also known as a solution. The definition of solution is homogeneous mixture. That means they're the same throughout. So it has uniform composition. And an example of this would be salt water. Air is a mixture. The air, the parts of air, which is about 78% nitrogen and 21% oxygen, with lesser amounts of carbon dioxide, water vapor, argon, different elements, that they are evenly distributed. And you know that because when you walk, you don't all of a sudden hit a pocket of nitrogen and start gasping for oxygen. You know that gases are evenly distributed, so it's the same throughout. Solutions do not have to be liquid. They can be a gas and a gas. They can be a solid and a gas. As we saw with the alloys, they could be a solid and a solid. And this ends our little discussion of the classification of matter.